Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do. But y'all, it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor mathematicians as we co-create meaning together. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. So, Kim,
Yeah.
here is a friendly reminder that we have online workshops that launch only 3 times a year. And
Yep.
one of those times is coming up. So, teachers, leaders, math learning friends, get your funding ready because registration opens in January for workshops that they'll launch at the end of the month. If you are planning to take a workshop this coming January, this is your time to get ready, get your funding, get your permission, all the things, get it ready.
Super exciting.
Woo!
Yep. So in previous episodes, we did a short series on the open number line, and that was wildly successful. So we thought that we would spend some time diving deep into one of our other favorite models, the ratio table.
The ratio table. What in the world is a
Yep.
ratio table? Ratios. Like I remember vaguely hearing about ratios in middle school. Like, what are you? Oh, so if I may, why is the ratio table one of, and literally short list, one of our favorite mathematical models? What is so amazing about the ratio table? So if I may, I'm going to give kind of a little bit of my informal definition of a ratio table first.
Yeah.
A ratio table is taking the relationships that naturally mathy people use to solve many problems, multiplication, division, proportional reasoning problems. It's taking the relationships that somehow they just kind of have a natural aptitude that they kind of use those relationships to solve problems. A ratio table is a way to make that thinking visible. It's a way to pull it and make it visible so that we can then point at it and discuss and talk, and by using it, develop that kind of reasoning in the learner's head at the same time.
Yeah.
So I'm thinking there is this group of people out there that have this sort of natural, there's a word I'm looking for, affinity. That's the word I want. This natural affinity for seeing patterns and then using those patterns. And the more they do, the kind of more relationships and connections they build in their head, but kind of naturally, just like some kids, we've talked about this before, some kids kind of naturally pick up a basketball and start to dribble and they between their legs and they can spin the ball on their finger. And not everybody has that talent, but you can learn to do that. You can watch it and you can make sense of it and you can try your best to do that. We all have kind of natural talents that we lean towards. The ratio table is a brilliant way of taking what some people have kind of naturally done and opening it up to the rest of us.
Yeah.
The rest of us
Yeah.
get a chance to reason the same way. Yeah, go ahead.
Yeah. Well, I was going to say that I think you might get into this, but I think that some of us who did kind of those mathy things and thought about patterns and relationships, you're saying it's opening it up to others so that they can make sense. I think it also made things more clear for me.
Mm.
So when
Nicely said.
you introduced that model to me, I was able to do even more because I had a model.
Yeah, that makes a lot of sense. And for all sorts of reasons.
Yeah.
You had a model. We could talk about it. Like I said
Yeah.
earlier, it was point outable. We could
Mhm.
discuss it together. And the more you use it, the more you develop that reasoning and thinking, and
Yep.
we all just get better at it. So it's
Yep.
super cool. All right. So brass tacks. What is a ratio table? It's a paired number table.
Mhm.
So pairs of numbers, but it's very specific paired number table. It's not just any table where you have, X's and Y's or values in the one column and the other column. It's very specific in that the ratios of every X to every Y are equivalent. Those ratios are equivalent. So if I look at any of the paired numbers in the table, the ratio of the X to the Y, or the one on the left-hand side to the one on the right-hand side, is equivalent to every other ratio in the table of the left-hand side to the right-hand side. And so it's a very specific kind. Now that might, you're like, Pam, what does that even mean? Well, then we would definitely want to do it in context. And that makes a whole lot more sense. And we'll do a lot of that today. But just a couple of other brass tacks things. Ratio tables can be both horizontal and vertical. When I just said the values on the left side and the values on the right side, I was thinking about a vertical ratio table. If I was thinking about a horizontal ratio table, then I would think about the ratio of the numbers in the top row to the numbers in the bottom row.
Mhm.
Um, and again, it's all about those ratios being equivalent. We would suggest that as you work with ratio tables, you introduce ratio tables in context. So you have
Mhm.
context that makes sense, and then stay in context as much as you can until students are really starting to get a feel for it. And then decontextualize and let kids make the mistakes they're going to make when there's not context to lean on, and then bring back context to help them reason about the things that they're going to do. And that will come up a little bit later in today's episode about how to do that. A couple of other things to consider as you work with ratio tables, specifically as we watch teachers use ratio tables. Kim, I'm just aware as I'm talking about things about ratio tables, I almost wonder if this list of things I was going to talk about would be better after we did some work with it. I don't know. I
Mm,
mean, I guess
mm.
I could keep talking about it. We can mention it again.
Yeah.
Okay, let me just mention them briefly, not discuss too much, and then we'll bring it back up. One of the things that we see novice ratio table teachers do is they won't ever erase. So
Mhm.
we'll be working in a ratio table and they'll model the thinking, they'll represent it, making it visible, but then they leave it all up there. And there's all these marks and different things, and it just gets really muddy and crazy. And so we definitely there are strategic times to erase. There's a brilliant inverse relationship that shows up in a ratio table between multiplication and division.
Mhm.
So that's a really nice part about ratio tables. We definitely want students to still see multiplication and division symbols. We want them to see multiplication and division equations. We even want them to see the housetop, if we could call it that, the kind of way that
Mhm.
long division is written, but not then have that be, oh, now thou shalt do the steps of the long division algorithm.
Right.
It's just a way of representing the relationships. Oh, it's this divided into that. Or it's the number under the housetop is being divided by the number sort of outside the housetop.
Yeah.
We need students to be able to read that. It's just that with ratio tables, when they see those multiplication and division symbols or notations, it means a different kind of thinking. And that kind of thinking can be done on a ratio table.
Yeah.
Is there anything you want to add to my little description of ratio table?
No, I think it's pretty solid. I
All right.
like. All
So
right.
let's get down. Let's do some stuff with a ratio table. So
Okay.
listeners, we're going to invite you to grab a pencil and a paper. Oh wait, a pen and a paper.
No, pencil.
I can't believe I said pencil.
It's because it's the right thing to grab.
Oh man. Okay, I have to just tell a quick funny story. I was recently in South Africa and we were talking about when you just said the right kind of thinking. They drive on the other side of the road.
Mhm.
And I would say to my good friend who was driving, I'm like, "You're driving on the wrong side of the road." And she would say, "No, I'm driving on the other side of the road, not the wrong side of the road." Who's driving on the wrong? Anyway, so it was the right side. I mean, right is a funny word, right? The correct side. Because we do drive on the right side of the road in two
Yeah.
ways, the correct and the right hand side of the road, which she would take umbrage with. No, it's the left. Anyway, it made me slightly dizzy to drive on the left hand side of the road, but all is well. Okay, so the right way of thinking, here we go. Or the right way of writing with a pencil? Yeah. All right, Kim, I'm going to throw out a few questions and we're going to talk about how a ratio table can be helpful in reasoning through those questions.
Okay.
So I'm going to start with one box of Smarties. Do you know what a Smartie is?
Yes. It's a
Okay, so
fabulous candy. Okay.
it's not those so the things in the US they're like chalky. They're kind of like these funny disc shaped things. They're
Mm-hmm.
like yeah, so I don't mean those.
Oh,
I mean they're kind of like M&M substitutes. And
no.
and you can get them in Canada and you can get them in South Africa. And I was just recently in both of those countries, where they were like, "Hey, you have to try Smarties," and I was like, "Or M&Ms." Anyway, so we're just for our international listeners today. It's going to be Smarties, and you can picture whatever you want Smarties to be. They could be those chalky things if you like them or whatever. But we're going to picture a container that has a bunch of those Smarties in it, and I'm going to say that one of those boxes, one of those containers, has 72 Smarties in it. Yum.
Okay.
That's a lot of Smarties.
It is a
So
lot.
on a ratio table, Kim, I'm just curious, what did you just write down?
I drew a horizontal line and I wrote 1 to 72. So 1 on top and 72 on the bottom of the line.
And you do usually use horizontal ratio tables,
I
don't you?
do. I do. I just get more board space that way.
And I just wrote a vertical ratio table
Yeah.
where in the left-hand column, I wrote box and 1, and on the right-hand column, I wrote Smarties 72.
Mhm.
All right,
Okay.
cool. So what if we had 2 boxes? How many Smarties?
That would be 144 Smarties.
Because if you
Double the number of boxes, then you double the number of Smarties.
and that makes sense. Cool.
Mhm.
What if you had 4 boxes of Smarties?
288
288
Smarties.
boxes?
Smarties, sorry. Four. So I did twice the number of boxes from 2 to 4 would be twice as many boxes, which would be twice as many Smarties. So that's 288.
Because you doubled the
Mhm.
144.
Mhm.
So, Kim, weren't you supposed to, though, go back to the 1 to 72? Weren't you supposed to multiply the 72 by 4? Like, were you sort of cheating there a little bit? Like, or
I used a nicer relationship for sure because I don't want to do 72 times 4. I'd rather double the 2 boxes, which was 144 Smarties.
yeah, why not? Right. And especially since you already had it in front of you. It'd be
Yeah.
one thing if I just said, hey, 1 box for 72, find 4. Well, then you might think about 4 times 72. But since we already had the 2, might as well
Yeah.
use it. Cool.
Yeah.
All right. How about,
And
oh,
on
go
my
ahead.
ratio table, since we're describing kind of what my mine looked like, I actually wrote an arrow with the times 2 from 2 to 4 and an arrow with the times 2 from 144 to 288.
So did I.
Okay.
Cool.
Very good.
And so we're sort of keeping track. Like you said, if you double the number of boxes, you double the number of Smarties. And that makes sense. We can reason about what's legal to do in a ratio table using that context.
Mhm.
All right. What about 8 boxes of Smarties?
That would be 576.
How do you know?
So if 4 boxes of Smarties was 288 Smarties, then again, I doubled the number of boxes and doubled the number of Smarties.
How did you double the 288? I'm super
Oh, I
curious.
knew you were going to ask me. So I I actually doubled from left to right, which I know is weird, and I feel like we might have talked about this at some point that I probably theoretically could have done a nicer job and been less double checking myself if I had doubled 300 and then backed up 24. But for whatever reason, I was in the mode of going left to right. So I doubled the 200, doubled the 80, doubled the 8.
So did I actually.
Did you really? All
I
right.
did, yeah. And then I thought I
Okay.
could have doubled. Let me slow down your double 300. So if you're going to double 288,
Mhm.
instead double too much, double 300. But you
Mhm.
doubled 12 extra twice
Mhm.
because 88 is play I have you need a little bit. If I have
Mhm.
88, you need 12. So that 12 to get to 100 or to get that 300. Cool.
Mhm.
All right. So let's see. We've got 2 boxes, 4 boxes, 8 boxes. Often I will ask students right now, what do you think of next? And they will often say, oh, 2, 4, 8, 16. And I'll go, nope, good
Mhm.
try.
Mhm.
10.
Yep.
So
Yep.
10 boxes of Smarties. How many Smarties?
720 Smarties.
Whoa, that was kind of like, did you use the 8 boxes to help you with that?
No, I didn't. I actually went back to the one box, which I've kind of ignored this whole time.
Before you talk about that, could we talk about a possible 8-box
Uh-huh. Yeah.
strategy?
So 8 boxes was 576 Smarties,
Mhm.
and 2 boxes is 144 Smarties. So I could add the 8 boxes and the 2 boxes and those corresponding Smarties, which would be 720.
Cool. You could add the 144 Smarties to
Mm-hmm.
the 576. Yeah, nice.
Mm-hmm.
But
Hmm.
instead, I thought we decided not to go back to the one. Earlier we said don't go back to the one,
Yeah. Yeah.
just double from where you are. But
Yeah.
but so like, why are you switching up here?
Um, I think because I know a relationship between 1 box and 10 boxes,
Which is
times 10.
ah,
And you know
so
what I'm actually thinking about right now is
mhm,
I'm recording what I'm thinking about on a piece of paper,
mhm,
and I have that times 2 and times 2 on there, and I you talked about earlier about erasing at pivotal
mm,
times,
mhm.
and I'm trying to decide if for the sake of niceness on my paper, I want to erase those times 2s. Because if I were in the classroom,
Mhm.
this would be a moment where I would erase the 2 previous times 2s so that I could make a nice going from the 1 to the 10, make it a nice, real clear times 10 relationship.
Because when things are clear, kids learn better. Why would you want it?
Because I want to emphasize the relationship that's being used, and I think it's going to get a little muddy. I don't know how many questions you're going to ask, and
Mhm.
we've had the conversation of times 2 already, so I'm ready to move forward to the new relationship.
And is it also true that what's important are the number of boxes and number of Smarties at this point to
Hmm.
mess with the finding the number of Smarties in 10 boxes?
Hmm.
The doubling that you did to get up there is no longer
Right.
relevant, right?
Right.
So we can sort of
Right.
get rid of the irrelevant stuff and kind of focus on the
Yeah.
times 10. And
Yeah.
72 times 10 is indeed 720.
Yeah.
Nice. A fine relationship to use. Cool. How about 9 boxes of Smarties?
So 9 boxes of Smarties. I could do a couple of ways.
Hmm.
The first way I'm thinking about is I could think about 8 boxes plus 1 box,
Hmm.
or the one I really want to use is 10 boxes minus a box to get to 9 boxes. So that would be 720 Smarties minus 72 Smarties.
Hmm.
And I think that is 648 Smarties.
And how do you know?
I actually am thinking I kind of want to check myself, to be honest with you. So down below my ratio table,
Hmm.
I wrote 720 and I want to remove 72. So I'm removing 20 to get to 700. And then I'm removing 52
The remaining 52. Uh-huh.
to get to 648.
Because if I have 52, you need
Hmm.
48 to make 100.
Yep.
Yeah,
Yep.
I agree. 648. And I actually subtracted the same way. I started to wonder about shifting it a little bit, and I didn't get a chance because you were talking. But like 72 is 28 from 100.
Hmm.
So I could think about 720 subtract 72 as something subtract 100. I'd have to,
Hmm.
if I added 28 to the 72, I'd have to add 28 to the 720, and that would be 748. So 748 minus 100 is also 648.
Hmm.
And I don't know if anybody finds it interesting. I actually had to say that out loud in order to do it.
Mm.
So that was less me explaining what I was doing and more me saying it out loud so that I could actually do the computation.
Yeah.
In other words, I can't talk and do it at the same time, or I can't talk about something else and do it at the same time. I have to.
Yeah.
So anyway, I don't know if you care. Okay, so so you could have done the 8 box plus the one, but only really if we already had the 8 boxes, right?
Right.
Like
Right.
if you're walking down the street and I said, "Hey Kim, one box has 72 Smarties. How many are in 9?" Which strategy, the 8 plus the one or the 10 minus the one, do you think you would gravitate toward? If you didn't have all this work that we'd done before,
Oh, for sure. The 10 boxes minus 1 box.
because
Because finding 10 times something is pretty doable.
yeah, that makes sense.
I would have to walk through doubling to get to the 8.
Right, right, because you don't just know 8 times 72, but 10 times
No.
72, bam, there it is.
Yeah.
So you
Yeah.
might as well use it. Cool. All right, how about 5 boxes? 5 boxes,
Mm.
please? Pretty please. 5 boxes of M&Ms?
5 boxes is going to be 360 Smarties.
How do you know?
I knew 10 boxes was 720, so half the number of boxes would be half the number of Smarties.
How did you do half of 720? I'm curious.
Hang on, I'm writing on my ratio table. I did I did half of 700 is 350 and half of 20 is 10. So 350 and 10 is 360.
Nice. Do you want to know what I was thinking?
Yeah.
Half of 72 is
Mm,
36.
yeah.
I didn't used to know that, but I've played around with doubling and halving a lot. I
Hmm.
shouldn't say double, like doubling and then halving, not the strategy
Hmm.
doubling and halving, but doubling a lot and then having a
Hmm.
lot. And so I just sort of that one I know now that half of 72 is 36.
Nice.
Cool. Okay. So let's see, that was 5 boxes of Smarties. You could have also used 4 boxes in one box if you
Yeah.
wanted to. And we often will ask students to share that one. But then almost kind of so we have this sort of shock value of, oh, but you could just do half of 10. Bam,
Hmm.
because it's so
Hmm.
nice. Because 5 is half of 10. Yeah. How about 15 boxes of Smarties? What you got for that?
1080.
How do you know?
10 boxes was 720 and 5 boxes is 360. So that's 1080.
Cool. So just like we could say 5 times anything is half of the 10 times that thing, how might you verbalize your 15 times what you just did?
Say that one more time.
If we could generalize to say, "Ooh, I could find 5 times anything by finding 10 times that thing and dividing it in half to get
Hmm.
5 times that
Hmm.
thing." What if I said, "But now I want 15 times that thing?" How
Mm.
could you Yeah, go
You,
ahead.
you could think about 10 times that thing and half of the 10 times that thing. So another 5 times the thing and put those together.
And add them together to get 15. Cool. And
Yeah.
you could do that
Yeah.
with 15 times anything. Well, that
Yep.
seems kind of slick.
Yeah.
All right, I really, really like Smarties. So 100 boxes of Smarties. How many Smarties?
100. I'm actually going to go with 7,200. And I know you're going to
Okay.
ask me how I know.
Yep.
I decided to go back to the 10 boxes and scale up by 10 again. So
Ah,
10 times 10 is 100. So 720 times 10 is 7,200.
nice, nice.
Yeah.
And I've heard lots of people say at that point that they're thinking about 172s and that that's equivalent to 72 100s,
Hmm.
which is an equivalent name for that 7,200 is 7,200.
Yeah.
That's another way of thinking about that. Cool.
Yep.
Okay, that's ridiculous, Kim. We cannot have that many boxes of Smarties.
Mhm.
We're only going to have 99. So how many boxes of Smarties would have how many Smarties would be in 99 boxes?
7,128.
How do you know?
100 boxes you asked me about was
Mhm,
7,200,
mhm.
but I need one less box of Smarties, and that's 72 less. So 7,200 minus 72 is 7,128.
Okay, so on your paper, did you write down 7200 and underneath that 72, draw the line and
No,
start to
no.
borrow, regroup all the cross the outies and how did
Thankfully, no, no.
okay, but I mean that's subtraction across zeros is often a problem. Teachers are like,
Huge.
"Oh, help us
Yeah.
like how do we do that?" So how were you thinking about 7,200 minus 72?
So in 7,200 or 7,200, you have 7,100 and then another 100. So I kind of set aside in my head the 7,100 part,
Okay.
and I played a little I have you need with 72 and the extra 100. So I thought about, given that extra 100 that I had broke apart from the 7,200, what would I have you need be for 72? And I know that that would be 28. So then I put the 28 back with the original 7,100.
Nice. And I just drew on my paper to make that visible. I drew a number line and I put 7,100 on the left and I put
Mhm.
7,200 on the right. And I kind of said that then I made a big jump between them of 100, right? So
Mhm.
7,100 plus 100 is 7,200. And then then there's that 100 you were talking about. That 100
Mhm.
sitting there. And if we need to subtract 72, so I made a jump back of 72. I know I have you need is 28. So then I made a jump forward from the 7,100 of a jump forward of 28. And then I can just ask myself, where is that?
Mhm.
Where do those meet? Oh, at 7,100
Mhm.
and 28. Bam.
Nice.
Yeah, nice. Okay, cool. We're almost there. How about 50? 50 50 boxes of Smarties. How many Smarties
Mhm,
are
mhm.
Mhm,
I went back to the 5 boxes that
mhm.
you had asked about earlier, and I, did 5 boxes times 10 would be 50 boxes, and 360 Smarties times 10 would be 3,600 Smarties. So I did
Nice.
3,600.
So you could think about 50 based on the 5. So
Mhm.
if you needed 50 times anything, you could say, well, I could find 5 of them. Oh, by
Yep.
getting 10 of them. So
Mhm.
10 of them could be half of that's 5 of them, and then scale that up, like you said, times 10 to get 50.
Yep. Yep.
You could also have gone from the 100, right? We had the
Yeah,
100
yeah.
up there. We could have cut that in half.
Yep.
Cool. Nicely done. How about 49 boxes of Smarties?
Well, since I just did the 50, and that was 3,600, then
Mhm.
I could do kind of like I did the 99 from the 100. I could do
Mm,
49 from the 50 and just remove 72. So that would be
from
30
from
from the 3,600. So remove
mhm,
72 Smarties from the 3,600 Smarties
mhm.
because it's one box less and get 3,528.
And you just solved a whole lot of multiplication problems, thinking and reasoning, using what you know, using multiplicative relationships.
Yeah.
And I would suggest as we do this kind of work with students, they build those relationships more and more in their minds until it becomes sort of second nature. It's an
Yeah.
intuitive thing that it's almost like they say, can I use what I know? And you're like, well, what's up there? What do you already have? What do you what? And as we're doing a string like this, there's a bunch of things that we've already solved that they can use. So what happens when they see a problem in the wild? Like if we literally were to say, hey, you got 72 Smarties in a box and you're looking for 49 boxes, could they say to themselves, well, let's see, 49. Ooh, that's almost 50.
Yeah.
50, that's half of 100. Or like you said, 50, I can scale up from 5. Ooh, so if I can find 10, I can cut that 10 and a half to get 5. I can scale that up from 5. Or even a middle school strategy could be, could I find half a box? Now I've got point 0.5
Hmm.
and then scale that point 0.5 up to 5 and then to 50 or just from point 0.5 to 50 and go that
Yeah.
direction and then take off one to get the 49.
Yeah.
Lots and lots of multiplicative relationships that we can do using a ratio table to help students reason the way mathematicians are reasoning about multiplication. Super cool. Anything else you want to say about ratio tables?
Um, no, I don't think so. I'm looking at mine, Pam, and there's a lot happening here. There's a lot happening.
Yeah.
I think we can continue to have some more conversation about critical moments to erase
Mm.
as we keep talking about ratio tables. Yeah.
Yeah, we could also talk about which questions I would ask when, which
Mhm.
strategies I would share first,
Mhm.
why this order of problems, lots of
Yeah.
things that are kind of embedded. We are so excited about ratio tables that we're going to continue to talk about ratio tables. So tune in next week for
Yeah.
more on our fantastically favorite model, the ratio table.
Yeah.
And again, a friendly reminder that we have online workshops that only launch 3 times a year. And one of those times is coming up. So I'm mentioning it today. So you have time to arrange for funding, get your planning in order so that when registration opens in January, you are ready. All right. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable. Thank you for listening and making math more figure outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.